Let's do some practice problems for factoring. For number one, we want to first determine if there is a greatest common factor. We're going to look at each of the terms and see if there is factors that go into both of those. So if we look at the 18 and 30 to start off with, we can see that a 6 goes into 18 and it goes into 30. There is also an a squared that shows up in both of those terms. So that comes out in front. And then we're going to look at what goes in the parentheses. If we divide 18 by 6, that leaves us with a 3. And if we took out that a squared, we've taken it out. So that just stays 3. If we divide negative 30 by 6, we get negative 5. The a squared, taking that out, leaves just 1a. And then we have b squared. All right, so that is fully factored. We can't do any more factoring. This one also we want to look for greatest common factor. It's always what you want to start off looking for, kind of the first thing. So if we look at the 7 and the 28, we see that a 7 goes into both of those. And an x squared shows up in both of those terms. We take the 7 out, we're going to be left with x squared. So if we take the 7 out, we're just left with 1. If we take x squared out of x to the 4th, we're left with x squared. If we take 7 out of 28, or negative 28, that leaves negative 4. And if we take the x squared out, we have no x's. Now let's look at what we have in parentheses. That's one of our special cases. It is the difference of two perfect squares. So that means that we are going to have two sets of parentheses. The first position, we're going to put in the first thing that's squared. Well, that is x. So we have x and x. And the second position is the second thing that is squared, which is 2. 2 squared is 4. And in between, we have one that is plus and one that is minus. For this example, we've got 4 terms. A clue to what to do when you have 4 terms or more than 3 terms is you're going to want to group. So I'm going to just rewrite the polynomial 3x squared y minus 6x squared minus y plus 2. And in grouping, we separate it into 2 groups and then find the greatest common factor for each of those groups. So we're going to find the greatest common factor of this group and the greatest common factor of this group. We can bring out a 3x squared from this first group. And we'll be left with, in the first term, a y, and in the second term, we're left with a 2. From the second group, we can factor out a negative. That's the only thing that we can factor out. So we can bring out a negative, and then we're left with positive y. If we take the negative out, we're left with positive y. And if we take a negative out of plus 2, we are left with a negative 2. It just changes the sign. Okay, that ends up just like we would expect, where in parentheses for both groups we have the same factor. We bring that factor out in front. So here's that y minus 2, and now we write down what we have left. From the first group we have left the 3x squared. Okay, that comes here to here. And from the second group, it kind of looks like there's nothing there. But remember, we can always put in a 1. It's like negative 1 times y minus 2. So if we bring that y minus 2 out in front, it leaves that minus 1. So that minus 1, that comes from right there. So our factored form is y minus 2 times 3x squared minus 1. Here we've got a quadratic. So remember, quadratic is when we've got degree equal to 2, and we are going to factor it in to 2 linear factors, 2 factors that have degree of 1. we can immediately write down the parentheses to put those factors in. Now, the leading coefficient is equal to 1. So when it's equal to 1, that means that in the first position, we're always going to have x and x. All right, we can write down that much without even thinking about it. Leading coefficient of 1, and it's a quadratic. We're going to have two binomials, and the first position is going to be x. Now, to fill in the other places here and here, we want to find the two numbers that multiply to the constant term, which is negative 18. We want to make sure we include that negative on there, and add to the coefficient on the x term, which is negative 7. Okay, so we need these two numbers. Well, we can kind of play around with the different things that multiply to negative 18 and add to negative 7. Well, we've got 3 and 6, which if one of those is negative, it'll multiply to negative 18, but they won't add to negative 7. If we have 2 and 9, that multiplies to negative 18 if one of them is negative, and we can also get negative 7 if we have a negative 9. So the two numbers are going to be negative 9 and 2. So you can see how those two numbers satisfy both of those equations. So that's what goes up in the factors here. We're going to have x plus 2, x minus 9. So the factored form of the polynomial of the quadratic is x plus 2, that factor times this other factor, x minus 9. We can always check our factoring by just multiplying it, by doing FOIL. So first times first, we get x squared. Outer times outer, we get negative 9x. Inner times inner, we get plus 2x. Last times last, we get negative 18. Combining those middle two terms, x squared minus 7x minus 18, which is what we started off with. So we know that our factored form is correct. This quadratic has a leading coefficient that's not equal to 1. So we can't just write down the parentheses and put x and x in there. We have a first step, and that is to multiply the leading coefficient, the 3, times the constant term, which is the negative 12. And that is going to give us a negative 36. Now we want to find the two numbers that multiply to negative 36 and add to, this stays the same as when the leading coefficient is 1. We want it to add to the middle term, or to the coefficient on the middle term. Okay, so we want to think of combinations of numbers that multiply to 36. Well, 3 times 12, 6 times 6. Neither of those are going to be able to add up to a positive 5. But what about 9 and 4? If we use a positive 9 and a negative 4, that's going to add to a positive 5. Now what we do with those two numbers is a little bit different. We're going to use those to rewrite the quadratic. The first term stays the same. We rewrite that plus 5x as plus 9x minus 4x, and then the minus 12 stays the same. And now we factor by grouping. We group the first two terms and the second two terms. We find greatest common factor from both of those. First group, we're going to be able to pull out a 3x. And we're left with x plus 3. The second group, we can pull out a negative 4, and we'll be left with x plus 3. Now, it's designed so this will happen. If it doesn't happen, then you want to check your work. The factor, the quantity is going to be the same for both of those. And then that comes out in front. So x plus 3 comes out in front. We write down the other factor with what's left over. So from the first group, it's the 3x. Okay, that's just coming from right here. And from the second group, it's the -4. So we want to make sure we include that negative. So that -4, it just comes from right there. All right, so this is our final factored polynomial, x plus 3 times 3x minus 4. Before we start to factor this one, notice that it's not in descending degree. So first thing is rewrite, so we've got descending degree. So 24x to the 4th minus 4x cubed minus 8x squared. Now I want you to think, what's going to be our first step here? Hopefully you're thinking greatest common factor. What factors go in each of those terms? Looking at 24, -4, -8, we can see that 4 goes into each of those numbers. And the biggest factor of x's is the x squared. So that's what's out in front. Now we go through and write down what's left over from each of the terms when we take out 4x squared. If we take 4 out of 24, we're left with a 6. If we take x squared out of x to the 4th, we're left with an x squared. If we take out 4 from -4, we're left with a -1. So just put the negative in there. We take x squared out of x cubed, we're left with x. If we take 4 out of -8, we are left with -2. If we take x squared out of x squared, we're left with no x's. So we get 6x squared minus x minus 2 in the parentheses. Now here we've got a quadratic, so we want to keep factoring. Here this is a quadratic that has leading coefficient not equal to 1. We want to multiply the leading coefficient times the constant. We get -12. We want the two numbers that multiply to -12 and add to the coefficient on the x term, and that coefficient is a -1. Okay, we go through all the possibilities of what that could be, and we're going to land on -4, +3. All right, let's look at what we do with those now. We have the 4x squared is going to just kind of carry along here. We want to keep that out in front. And then we rewrite that middle term as -4x plus 3x. You can see if we combine those, we're going to get back to that -x. And then we have the -2. This is where we group. So we're going to group the first two terms, the last two terms, and now find the greatest common factor. Okay, the 4x squared is going to keep coming along. It doesn't disappear. I'm going to put it in parentheses to kind of keep it separate. Now let's find the greatest common factor of 6x squared minus 4x. We can factor out a 2x, so that comes out in front. Then write down in parentheses what's left over when we factor that out. It's going to be a 3x minus 2. Now we go to the next group, and the only thing that's going to factor out is a 1. So we're going to have a +1, and then what's left over, which is 3x minus 2. And we know that's right because these match. Those are the same. Now, this 4x squared, we keep just dragging that along with us. And now we can bring that 3x minus 2 factor out in front. And now we're going to write down what's left over. we have a 2x and a plus 1. This is one of our special cases. This is the difference of two cubes. The difference of two cubes and the sum of two cubes always follow the same pattern. For the difference of two cubes, it looks like this. If we have a cubed minus b cubed, that's going to equal a minus b times a squared plus ab plus b squared. For the example, a is y, b is 1. So we really are going to make replacements of a with y and a b with 1. So we're going to take y minus 1 times y squared, and then we want plus ab, so plus 1 times y, so that's just y, and then plus b squared, well 1 squared is just 1, so it looks like that. This one also has cubing. Before we apply the pattern, we want to look for the greatest common factor. We look at each of those terms, 16 and 54, and we see that 2 goes into both of those. So we bring a 2 out, we'll be left with 8x cubed plus 27. Now we can recognize that we have got the sum of two cubes, so it follows this pattern. A cubed plus b cubed equals a plus b times a squared minus ab plus b squared. So if we identify a and b, so 8 is 2 cubed, so a is just 2x. So then if we cube that, we would get 8x cubed. And 27 is 3 cubed, so b is 3. So the 2 comes along, and in the first set of parentheses we want a plus b, so that's 2x plus 3. In the second set of parentheses we want, first of all, a squared, so we're going to square a, so we're going to square 2x. So we square the 2 and we square the x, so we get 4x squared. So 4x squared. And then a times b, so 3 times 2x, we'll have plus 6x. And then b squared plus b squared, so that's a 9.